Hello, Algebra 2s. Here's a quick review of 2-3, factoring by grouping. Think about finding that common variable or constant that can be divided out of every term. Well, an expression can be divided out the same way. So when you have a polynomial with 4 terms, you can use your associative property to group each of those terms. Now keep in mind, these are all designed to work out. So when you're looking at a 4-termed polynomial, think about dividing it into 2 groups of 2 and then finding that common factor. Let's work on some. Okay, so let's work on some of these together. So this is the practice from 2-3, which is factoring by grouping. So what we're first going to do is here look for any common factors that can be divided out. Now this only has, of course our first one is a little weird. This one has 1, 2, 3 terms. So I'm not going to be able to do the associative property grouping. All I'm looking for here is that GCF to come out. So what I'm going to do when I'm finding my GCF, that's going to be which is a common term. 13, 39, 26. Each of these can be divided by 13. So I'm going to pull that out. I have 2 x's here, 3 here, 5 here. The max I can pull out is 2. 3 y's, 2 y's, 4 y's. The max I can pull out is 2. Let's take a look at what we have left. If I factor out my 13 and an x squared and 2 y's, that leaves me with 1 y left there. Factor my 13 out, that's going to leave me with plus 3. If I take 2 x's out, that's going to leave me with 1. Take 2 y's out, and I'm good. Here's my minus sign. 13 out, that's going to leave me with 2. 2 x's, that's going to leave me with 3 left over. Taking out 2 y's, that's going to leave me with 2 y's left. This is not something that's recognizable as far as what I can continue working with, so we're done. That's a good answer. This term has nothing but y's. This has nothing but x's, so no more common factors can come out. All right, let's take a look at this polynomial. It's a 4-termed polynomial, so I'm going to go ahead and use my associative property. Now we want to be careful with this sign and know that I've attached that negative to this 2. With these negative ones, if it's easier for you to rewrite it, please take the time to do that because you don't want to get tangled up in these signs. All right, so now instead of looking at a GCF across the whole polynomial, I'm just going to look at this one. I can take out 2 x's, and this is going to leave me with 1x plus 2. Now check this out. I can take out a negative 2, and that's going to leave me with 1x plus 2. I'm already excited because as you can see, what I have is this common factor here. Here I have an x plus 2. So when I pull that out, I have x plus 2, and what's left, if it's easier for you to cover it up, it's easy for you to see that x squared minus 2. Now, I'm not sure if I'm done or not, because do you see this squared? So I need to ask myself, can I factor this one anymore? This is the difference between, oh wait, this is not a perfect square. So because this is not a perfect square, I know I'm done and I'm good. All right, let's move on and check out the next one. Why don't you give this a go and check back in? Did you use your associative property and group? If so, look for common factors. How did you do? We pulled out a 5 and 2 x's out of this one, a 3 out of this one. Check it out. Here's my happy face. And now I can pull that out some more. Check out this one. It's not a 4 terms, it's only a 3 terms, so I can go back and do my number puzzle. I can try to think about these two binomial pairs. I can split my x's, and I can think about 8. All the factors of 8. 1 and 8, 2 and 4. 4 and 2 are my next one, so that's where my wraparound commutative property hits. So two numbers that multiply together to give me 8, that add to 6, here they are. So because this sign is positive, these match. Because this sign is positive, they're both positives. And it doesn't matter what order I put my 2 and my 4 in. Guess what? I'm done. Let's check out this next one. Do you see a GCF? Take out that GCF first and come back and let's compare notes. Did you see a -2 that came out? And don't forget, that changes every single sign. Now I'm looking at all the factors of 12, 1 and 12, 2 and 6, 3 and 4. Here's my wraparound. So I want to look for, now check out this sign. I know that this -2 hangs out as a coefficient. He just comes along for the ride. These x's are going to split. This is a negative sign, which means one of these is positive, one of these is negative. Now I want to find two numbers that multiply together to give me -12, but they're going to have a difference of +4. So when I look over at my t table, do you see these two numbers here? Have a difference of 4. Now I need to decide which one's positive. Do you see how I have more positives here? So my bigger number is going to be positive, and my smaller number is going to be negative. Here's my 3 factors, -2, and this expression, x plus 6, and this expression, x minus 2. All right, here we go. Don't be worried about this to the 3rd power, because I see a GCF that can come out. Why don't you go ahead and factor this out and come back and tell me what's left. So we've got 5x on the outside, x squared minus 5x minus 36. Let's take a look at our t table for 36. Go through the factors in order. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now remember, if these factors are not in your head, all you need to do is go to your y is equal to and type in 36 divided by all the numbers in the whole wide world, which is going to be x. And then I go to my table of values. And when I look at my table of values, I can see this chart that I've typed here. And it shows me a picture of all of the factors. So if they're not in your head, use your calculator. All right, let's break this up. This 5x comes along for the ride. Don't forget about him. And this x splits. That's negative. So think about what that means, a positive and a negative. So I want to look for two numbers that multiply together to give me 36, -36, and add together to give me -5, which means they will have a difference of 5. So we go ahead and find those numbers right here. And we have more negatives because this sum is negative. So my 9 goes here and my 4 goes here, and I'm all done. All right, so pause the video and then check back for the answers on your last 4. You try. So for this next one, I'm going to try to do guess and check because 5 and 2 are prime numbers and they only have 2 factors, 1 and themselves. So I know my 5y squared has to split between 5y and y. This is going to be negative, which means that my signs are not going to match. Notice I switched to pencil because I'm going to have to test to see if this one's positive, this one's negative. If this one's negative, this one's positive. And this could be a 1 or it could be a 2. If this is a 1, this one's a 2. If this one's a 2, this one's a 1. Those are all of my choices. So how do I know which sign and how do I know which number? I'm going to practice by doing some foiling. So I'm looking for my O and my I to equal positive 3. So 5 times 1 and 2 times y is going to give me a difference of 3. So what I already know from just looking at this is that my 2 is going to go here and my 1 goes here. Now let's check out signs. I need more positives. So my 5 times 1, this one has to be positive, and this one has to be negative. Then I have positive 5y, negative 2y is going to be equal to positive 3y. So I got it. Once I pull out my pencil and I can check my guess and check, sometimes I end up erasing, but it's a pretty good deal to practice that and look for your O and your I of your foil. All right, let's look here. I see a common factor. So 2 can come out, and that's going to leave me with 2a squared minus 9a's minus 5. So guess what? I'm going to guess and check again. I know that my 2 and an a goes here, and I know that 1a goes here. 2a times a is 2a squared. Now I got to think about my 5, and I'll go back and get my pencil. This is negative, so either this is positive and that's negative, or vice versa. Either this is 1 and this is 5, or vice versa. So I'm going to do my FOIL to see how I get an inside product of 9. Well, I know already if it's 2 and 5, that adds to 7. That's not going to work, and I'm looking for a difference. So I know right away that this one has to be a 5, and this has to be a 1, because then I get a 2 times 5 is 10, and 1a, so their difference is going to be 9, and I need more negatives, so that means that this is going to be positive, and that means that this is going to be negative. Let's see if it works. 2a times a is 2a squared, and then we have 10a that's negative, 1a that's positive. When I add them together, I'm going to get that negative 9. So guess and check is a great strategy. I love it how you can spin those numbers around in your head and make that work out and figure out signs and such. All right, let's check out 9 and 10 real quick. I know a 5 comes out, and I know an x squared comes out. Let's see what's left. X squared plus 2x minus 8. Okay, so let's look at the factors of 8. 1 and 8, 2 and 4. A difference of 2, I think I see it. Here's 5x squared. Now let's factor this trinomial. Split your x's. Negative sign, which means one's positive, one's negative. I have more positives than negatives, so here's my difference. And I'm going to have a positive 4 and a negative 2. 4x and negative 2x gives me positive 2x, and I'm done. All right, let's check out a common factor. And I'm going to take a negative 2 out of this because I want my leading coefficient to always be positive. So it's going to give me positive 5x. That's going to give me negative 3x and negative 2. See how that negative changed every sign. So my negative 2 comes along for the ride. I'm going to set up my two binomials, 5x and x. This splits into these two. I know I have again a positive, so let's get my pencil, because either this is positive and this is negative, or this is negative and this is positive. Either this is 2 and this is 1, or this is 1 and this is 2. So I just need to see, how do I get an inside value of negative 3? So if I have 5 times 1 and 2 times 1, that's going to give me a difference of 3. So I think I've already decided that my 1 goes here and my 2 goes here. 5x, 2x, they have a difference of negative 3, and I want more negatives than positives, which means this is going to be negative and this is going to be positive. Let's double check that. 5x times negative 1 is going to be negative 5x. Positive 2 times x is going to be positive 2x. They add together. So we got it. All right. Tune in to the next video.